Have you ever wondered what it would look like to travel near the speed of light? What kind of mind-bending transformations would the universe reveal if we could reach speeds so fast that even time itself would change? The laws of physics, as we know them, suggest that approaching the speed of light would alter everything we understand about reality. Today, we'll take you on an extraordinary journey to explore the visual and physical effects of traveling at such unimaginable speeds. So, strap in, and get ready for a cosmic adventure that will make you see the universe in an entirely new way. First, let's start by understanding the difference between speed and acceleration, a crucial concept in space travel. Imagine you are inside a spaceship preparing to launch. As the engines roar to life, you feel a powerful force pressing you back into your seat. This force isn't caused by the speed of the ship but by the acceleration, the continuous increase in speed. The faster the spaceship accelerates, the stronger the force you feel. It's similar to the sensation of being pushed back when a car suddenly speeds up, but imagine that multiplied by hundreds or even thousands of times. As we accelerate closer and closer to the speed of light, this feeling would become increasingly intense, almost overwhelming. Our bodies would feel the crushing force of acceleration, making every second heavier and more dramatic. Now, as our spaceship continues to accelerate and reach a significant fraction of the speed of light, we would start to notice something strange and utterly fascinating happening outside. The stars, which once appeared scattered across the sky, would seem to move forward and concentrate into a brilliant cluster directly in front of our ship. This effect is known as the aberration of light. Because we are moving so rapidly, light waves from the stars bend toward our direction of travel, making the universe appear as if it is reshaping itself before our eyes. The entire sky seems to be warping, drawing everything into a bright, compressed field ahead of us. This isn't just an illusion, it's a fundamental shift in how we perceive light as we move at near light speeds, giving us a surreal and almost alien view of the cosmos. But the transformations aren't limited to what we see. The changes extend into the realm of time itself, which brings us to one of the most mind-bending concepts of all, time dilation. According to Einstein's theory of relativity, the faster you move through space, the slower you move through time compared to someone who is stationary. This means that if we were speeding through the universe at near light speed, time on our spaceship would tick by much more slowly than time on Earth. While we might experience only a few hours or days on our journey, years, or even decades, could pass back home. Imagine embarking on a space adventure only to return and discover that your friends and family have aged far more than you have. It's a profound and even heartbreaking consequence of traveling at such extreme speeds, illustrating just how relative our experience of time can be. As if that isn't bizarre enough, our experience of space itself would change. We would encounter a phenomenon called length contraction. Objects outside our spaceship, stars, planets, and even entire galaxies, would appear to compress or flatten in the direction of our motion. It's as if space itself is being squeezed, making everything look shorter and more compact. From our perspective, distances that once seemed vast would suddenly feel much smaller. The entire universe would feel distorted, bending and compressing around us as we moved closer to the speed of light. This isn't just a visual trick, it's a real, measurable effect that shows how even the structure of space changes at such extreme speeds. As we continue our journey, the universe would put on a dazzling display of colors, thanks to the Doppler effect. This effect, which we often associate with the changing pitch of a passing siren, also applies to light waves. As we approach the speed of light, the light from stars ahead of us shifts to shorter wavelengths, causing a blue shift. The stars in front of us would begin to glow with a bluish hue, while stars behind us, moving away from our point of view, would shift to red, fading into the background. At extremely high speeds, some stars would become invisible to our eyes, moving beyond the visible spectrum into ultraviolet or infrared wavelengths. The universe would transform into a surreal light show, with colors shifting and fading in ways that are hard to imagine. It's a vivid illustration of how motion can dramatically alter our perception of the cosmos. Despite these fascinating effects, there's a fundamental limit we cannot overcome: the speed of light itself. No object with mass can ever reach or exceed the speed of light. The closer we get to this ultimate speed limit, the more energy it takes to keep accelerating. In fact, as we approach the speed of light, we would need an infinite amount of energy to go any faster. It's as if the universe has placed an unbreakable barrier around light speed, a cosmic speed limit that we cannot cross. This limitation is rooted in the very fabric of the universe, as described by Einstein's equations. Even with the most advanced technology, we would find ourselves constrained by the relentless laws of physics. But what if there were a way to cheat the system? Enter the concept of the warp drive, a theoretical idea that could revolutionize space travel. Instead of moving faster than light through space, a warp drive would manipulate the fabric of space-time itself. The idea is to create a bubble around the spaceship that contracts space in front of it and expands space behind it. In this way, the ship wouldn't actually be moving through space at faster than light speeds. Instead, it would ride a wave of distorted space-time. While it remains a distant dream rooted in science fiction, the concept of a warp drive tantalizes us with the possibility of traveling to distant stars without breaking the universe's speed limit. It's a reminder of how theoretical physics could one day transform our understanding of travel and the universe itself. Traveling near the speed of light would be an experience unlike any other, reshaping our perception of space, time, and the cosmos. From witnessing stars shift and colors transform to experiencing time in a way we can barely comprehend, the journey would defy everything we thought we knew. Yet, even if we can't reach light speed, the dream of exploring the universe continues to inspire us to push forward, to innovate, and to imagine new possibilities. Who knows what incredible discoveries the future holds? If you enjoyed this journey through the universe at near light speed, don't forget to like, subscribe, and hit the bell icon for more cosmic content. Join us next time as we explore the mysteries of black holes, the enigma of dark matter, and the secrets of the universe. Until then, keep reaching for the stars, and never stop wondering what lies beyond. While these relativistic effects seem extraordinary and difficult to grasp, they have been confirmed through rigorous scientific experiments and observations. For instance, time dilation isn't just a theoretical concept, it's a measurable reality that we've witnessed in the real world. Scientists have used atomic clocks, the most accurate timekeeping devices ever made, to prove that time runs differently depending on how fast you're moving. When atomic clocks are flown on high-speed jets and compared to clocks left on the ground, the ones in motion show a tiny but measurable difference in the passage of time. This effect, though minuscule at everyday speeds, becomes pronounced and extreme as we approach light speed. It's a testament to the incredible nature of our universe and the precision of Einstein's theory of relativity. The implications of relativistic travel extend beyond just scientific curiosity. If humanity ever dreams of reaching distant stars or exploring other galaxies, understanding and adapting to these effects will be crucial. Space agencies and scientists are already grappling with these challenges as they think about long-term space missions. What kind of technology would we need to protect astronauts from the intense forces of acceleration? How would we deal with the communication delays caused by time dilation? These questions may seem like science fiction, but they are becoming more relevant as we push the boundaries of space exploration. Our journey to understand and conquer these effects could shape the future of human civilization, transforming us from a species confined to one planet into true explorers of the cosmos. Of course, the dream of interstellar travel is tantalizing but also daunting. Even if we could overcome the immense engineering challenges, the psychological and societal impacts of relativistic space travel would be profound. Imagine the emotional toll on astronauts who might return to a completely different world, with friends and loved ones having aged or passed away while they barely aged at all. The isolation of traveling through the dark void of space, combined with the knowledge that time is slipping away differently for those back on Earth, would test the limits of human resilience. Yet, the desire to explore the unknown has always driven humanity forward, from our earliest ancestors who sailed across uncharted oceans to the scientists and engineers of today who dream of interstellar journeys. This leads us to a fascinating philosophical question: how does our understanding of space and time shape our sense of reality? If time is not a fixed and universal experience but a fluid and relative phenomenon, what does that say about the nature of existence? Are the moments we experience truly linear, or are they simply perceptions shaped by our motion through the universe? These questions stretch our minds and challenge the way we think about the past, present, and future. They remind us that the universe is far more complex and interconnected than our everyday experiences suggest, full of mysteries waiting to be unraveled. Finally, while we may never fully experience the extreme effects of traveling at near light speed, Our understanding of these phenomena already influences our world. Technologies like GPS, which we rely on every day for navigation, must account for the effects of relativity to provide accurate information. The satellites orbiting our planet experience time slightly differently from those of us on the ground, and engineers must make adjustments to keep everything in sync. It's a remarkable example of how even the most abstract theories of physics have real-world applications. So, as we continue to push the boundaries of science and technology, we must remember that our universe operates on principles that are stranger and more beautiful than we could ever have imagined.